Please welcome Mr. Geir Eidalsvik that will talk about MySQL to the 8th version.
Thank you. Yes, can you hear me? Yeah, it works. I'm Geir Eidalsvik. I'm living in Norway. I'm Norwegian. I've been working with MySQL for like 12 years. Last 10 years I've been heading the MySQL development and maintenance for 10 years now. I work for Oracle. So that's kind of the facts. So anyone not heard about MySQL whatsoever? Okay, none. Good. It's a good start. So anyway, I just want to recap the kind of basic MySQL in a nutshell. MySQL is an open source relational database. It's fully transactional with ACID. It's based on or run on top of the InnoDB storage engine, which is a textbook implementation of a relational database storage engine. Historical focus of MySQL has been online transaction processing, transaction with low latency, high throughput, good scaling. That's kind of the sweet spot of MySQL. It's also based on a very strong replication story used for read scale out and for high availability. We like to see ourselves as simple, solid, and secure. It's easy to use, and it's proven at scale. Users of MySQL are pretty much everyone, but for example, Facebook, Twitter, LinkedIn, we have GitHub here, I saw we have Booking.com, YouTube, you name it. So that's the user base, and many more, of course. So like back in 2008, I worked for Sun Microsystems. I was working on the Apache Derby project, another open source database implemented in Java, and specifically on the Sun Microsystems distribution called JavaDB. And then Sun Microsystems acquired MySQL, the company MySQL, in 2008, and I started working on MySQL 8. Later, Oracle acquired Sun Microsystems, and that's roughly around 2010. So Oracle has been kind of driving MySQL now for roughly 10 years. There has been major investments in re-engineering, features, quality, put out many major releases, 5.5, 5.6, 5.7, and 8.0 in this time frame. Kind of a context. Then I will dive into specifics about MySQL 8, which is the topic of this talk. And just the one tweet we had, one that represents a lot of users, that they see MySQL 8 as light years away from the 5.x series. And hopefully this talk will explain why. So I have divided this talk into several sections. The first I call the basics, which is SQL, JSON, GIS, character sets, collation, functions, and so on. What developers want and see kind of perspective. So one of the things that was kind of a little bit messy back 10 years ago with MySQL was the optimizer. So it was kind of a little bit of a spaghetti. Things happened all over the place, and it was a little bit hard to both maintain and to add new features to it. So over the last 10 years, we have spent significant time in re-engineering the optimizer. And we are at least now at the point where we feel that these 4 main phases of a textbook SQL optimizer have now been established and is stable. So you have the parsing step, where you actually parse the SQL statement. You generate an abstract syntax tree. You have the prepare phase, where you resolve types, do simple transformations that are not cost-based. Oops. And you generate a logical plan. And then you have the cost-based range optimizer and join optimizer, and which generate the physical plan. And then you have the execution phase, where we just re-engineered just a few releases ago, where we actually changed the execution model in MySQL, consolidated various ways of executing plans into one based on the Volcano model, which is also used by many other database systems, and producing the result set. So this has been a major re-engineering effort over 10 years. There is a hang here. Sorry about that. My computer just hanged. So I don't know how to get out of this. There we go. So one example, which in the cost base, the planning phase, we have implemented histograms. This is needed or beneficial to the optimizer to know the distribution on values in various table columns, so that the optimizer can make better decisions specifically about join sequences. Today, you need to explicitly generate or write analyze table, update histogram manually. It is fairly lightweight because we have sampling, so you go in and sample. You don't need anymore to do the complete table scan here. We are also now discussing how to always generate histograms on all tables, so this information will be always available to the optimizer. Another thing we did, this is more about the iterator executor, the new execution. We implemented this iterator trees based on the Volcano model, which is an abstraction of any operation and a tree of. So you ask the top level node, get me a row, and it then will do the calls down the hierarchy and return a row for any type of operation. So this is pretty standard way of doing execution in an SQL database. So on this basis, we implemented hash join, which is just another iterator in this model. And we replacing the historical MySQL block nested loop method with hash join. We do it in memory if possible, and we spill to disk if necessary. So it's used for inner equi-joins in 8.0.18, and the next release we will release a couple of months from now, we use it everywhere where we historically used block nested loop. And it will replace block nested loop. The main benefit here is performance in many cases. So a hash join is much more performant than a block nested loop. In the worst case, they are equal, but in most cases, hash join is better. On top of that, we implemented explain analyze. So this we did just by wrapping the execution tree with timing iterators. So explain analyze is essentially in addition to showing the query plan, you're also executing the query, and you give timing information and count on how much time you spent, how many times you iterated in the various on the various levels. There is an example here down below. Another big thing about 8.0 is that we moved away from, or we changed the default, but not only changing the default to UTF-8 4-byte, but we invested a lot of energy in optimizing. Now we have to start comparing up to 4 bytes all the time. And that is generally slower than comparing 1 byte. So we spent a lot of time in optimizing that, and we think that we have got a very nice and fast implementation of 4-byte character comparisons. Yeah, this is generally because we felt that this is where the market is. You need to support emojis, you need to support Chinese, Japanese, Korean, and all these sort of things. We also moved to Unicode 9.0 collations, and we support things like accent, case, and kana sensitivity, or not sensitive, any combinations really. So when it comes to major new SQL features in MySQL 8.0, one of the top one is common table expressions, so-called with clause. So a common table expression is just like a derived table, but its declaration is put before the select statement rather after the from clause. There are just few sketches, simple examples shown here in red with a non-recursive example and a recursive example. We support both. And the general advantage with a common table expression is increased or better readability. You can write your queries in a simpler form. It doesn't get so convoluted because you have the subquery in one place and you don't have to repeat it and stuff like that. And it can be referenced multiple times. One CTE can reference another CTE. And at least in our case, we have cases with improved performance as well. Another major SQL feature that we implemented in 8.0 is window functions, or the over clause. So a window function is essentially similar to the aggregation function like group by and so on. But while aggregation functions are kind of merging many rows into one row, a window function will keep the existing row in the result set, but typically add one or more columns to each row based on the calculation. There's a small example here. If you have a table with name, department ID, and salary, you can write, you can sum up the total salary for each department, for example, by using this over partition by department ID. And you see that on the right-hand side of the column there, you get the department total for each of the original node with the sum of the salaries for all the employees that work for that department. So this is typically more in the analytics landscape that you will use this type of functionality. You want to generate complex reports. It's a fairly complete implementation with frames and whatnot. This is just a very simple, basic example of what you can do here. We also added support for lateral derived table. Some people call it the for each equivalent of SQL. So for each kind of row in table T1, you do another query by referencing to the T1 column. It's essentially easier to write statements with lateral. So it kind of simplifies things a little bit. We also added functional indexes. This is kind of plugging a historical hole in MySQL. So before that, we have generated columns, so you had to generate a column and then create an index on the generated column. Now we directly support functional indexes. So there is a simple example here with column 1 plus column 2, so on, just to illustrate. Another, perhaps even more important motivation for us was our JSON story. So this, you can then create functional indexes or index content of your JSON document, including arrays. So you can index JSON arrays by a functional index and speeding up your JSON queries. Invisible indexes is just you can toggle an index to be visible or not visible. So in both cases, it's still maintained in the background, but if you make it invisible, the optimizer will not see it, so it will make its plans without this index. Two use cases. One is that if you want to, perhaps you think that this index is not really needed, you make it invisible while monitoring the system. And if everything works as before for a certain period of time, then you say, okay, I can drop this index. If you see that there are problems, then you can just make it visible again immediately. And the advantage over this approach is that you don't need to, perhaps if you drop an index, it can take hours to recreate it if you have a large table, right? So this is instantly toggling the index on and off. Or a stage rollout where you want to create your index, but don't overnight, for example, and when you come to work the next day, you want to put it in production while monitoring your system. So flexibility in that. We also finally added check constraints that have been missing for MySQL, which has been a very commonly requested feature for us. We can also use expression as default values, another small hole that has been in MySQL over the years. This is useful for specifically for types without literal values that you want to initialize a JSON, the JSON data type, for example, or a global unique ID, or you want to initialize a point or a geometry. These are good use cases for expressions as default values. We also implemented no wait and skip locked. This is kind of more a special purpose thing, but have some nice use cases. This is about locking. So one of the performance problems you can hit writing SQL or using a relational database is locking. You're waiting for someone else that holds a lock on a certain row, and that can create bottlenecks if there is a very many transactions or user queries want to access exactly the same row. You generate a bottleneck in the system. So if you, for example, want to implement a queuing where you potentially just need to pick a job, you don't care so much about which job, you can do skip locked, for example. You search for the thing and you just get the one that you pass those that are locked by others, and you take the first that is not locked. In this way you avoid contention. Of course, can't be used for everything, but this is something that people have requested to implement certain special functions in the system. We also have the no wait alternative where I want this row. If I can't get it, I will just go back. I won't wait for it. Right? I will do something else instead. We also added a few more functions. For example, bit operations are now available on all binary data types. There were restrictions on that before. We also extended regex support. So on the JSON side, the gray ones here are those that are present also in 5.7, MySQL 5.7, and the red ones are new ones in 8.0. So we added some very useful JSON functions, specifically the JSON array aggregate and the object aggregate. So array aggregate and object aggregates can be used to, if you have SQL queries and you want to create from the result of an SQL query, you want to create a JSON document. So then you wrap your SQL inside a JSON array aggregate or a combination of object aggregates, and you produce a JSON document this way. We also support JSON table, which do the opposite. I will explain that a little bit in the next slide. We also support no overlaps between arrays, for example. We have support for adding a JSON schema validation, and we have support for JSON array indexes, so we can index a JSON array. So the overall JSON story starts to be pretty nice. So JSON table, the typical kind of thing that you can do is to create a SQL table from a JSON document or from a query. So, so in this way, you move from JSON into SQL, and with the aggregate function, you can move from JSON from SQL to JSON, so you can move a little bit back and forth between SQL representation and NoSQL or JSON document store representation by using these two sets of functions, which is quite nice if you want to combine, for example, a document-oriented model with a relational model. And you can, in this way, by using these techniques, use SQL to join two different JSON documents, for example. MySQL 8 have also added full geography support that was missing from SQL until now. This is essentially about calculating from longitude, latitude coordinates on the surface of the Earth. You can do all sorts of geometry calculations directly by calling MySQL functions. You can calculate distances on the surface of the Earth or overlap between areas and so on and so forth. So, but MySQL 8 is not only a relational database, although it's kind of mainly a relational database, it is also a document store. So you can decide to use MySQL as a document store and just create your collection. You can get your collection. You can do CRUD operations like add, find, modify, remove directly from JavaScript. You don't need to know anything about SQL. You don't need to know anything about schemas or databases in general. You just create a collection, put in a document, get it out, find, modify, and remove documents. So we also changed we added some architectural components. For example, from JavaScript and Node.js, they interface to XDev API. There's an abstract interface that we created, and we have a Node.js implementation. And this, from this Dev API, we also talk over the X protocol, which is an alternative protocol to the classic historical MySQL protocol. So now we have two protocols. We kind of expect over some years ahead to slowly more and more use the new protocol because it's asynchronous, it has more nice features. But we expect to support the old protocol for the next 10 years. So this will be a slow thing. But you can use this today, and it will be gradually built out. And then on the server side of things, we have a plugin, X plugin. So then the client talks to the server through these layers. And the X plugin actually translates the incoming CRUD into SQL. So from the server perspective, there is nothing special here as it is now. And it works quite nice. Of course, we are then using our own JSON functions a lot on the inside. So the X plugin kind of translates the CRUD over to using JSON functions and SQL functions. But the document store is more than just technology. It's also it has its own documentation. It has its own, you can integrate it in IDEs. You have, explaining the syntax you can use and so on and so forth. But at the very high level, it's kind of very similar to what you can do with MongoDB today. So then I will move over to some operational concerns. So the first part is more kind of seen from the developer perspective. What can I do as an application developer? What kind of functions, what kind of SQL can I use, and so on. Here we put the focus a little bit more over to the DevOps or to the operators of the MySQL database, and which are typically interested in topics like securing, monitoring, managing, and upgrading the server. So first of all, we have a theme that MySQL 8 should be secure by default. So when you download and install MySQL in 3 minutes, you will get an instance that are secure by default for everything. So we worked here to minimize the attack surface, minimize process permission, minimize file permissions, minimize privileges, strong authentication, strong encryption. So this has been a theme. So you should feel safe, download MySQL, start it, and you will be secure. As part of this, we added a strong default authentication. So we switched the default authentication from 5.7 to something much stronger. We also worked a lot to optimize this. So there is this kind of trade-off between speed and security. So sometimes it requires a lot of work to think about a mechanism to balance right. We think that we have got a good balance here on the caching SHA-2 password plugin. In general, MySQL authentication is pluggable, so we can plug in other things, and you can also integrate with other authentication systems by having a different plugin. We also now support using the Unix socket or operating system login for the server. We have invested in our password management story. So some of it exists kind of in 5.7 as well, but it's kind of the whole package has now been completed, I guess, in 8.0. So we have password rotation policies and enforcement, password history and reuse protection, password strength evaluation and enforcement, password generation. We also have 2 passwords per user that can be quite useful in some kind of migration upgrade scenario where you want to change the password of users and applications. And we have brute force attack protection. 8.0 is also quite different than earlier version on authorization, specifically around roles. So we added standard implementation of SQL roles in 8.0. We also added information schema, standard SQL information schema support for things like applicable role, enabled role, role grants, and so on. This is just to have a view on what kind of roles and privileges do I have right now. We also did the privilege system much more fine-grained, so we now can set more specific privileges and control the privilege of a DBA or the operators much more fine-grained than you could earlier. Before, historically, MySQL had this super user privilege that if you got that, you could do whatever you want, and so you had that, but then now you can have specific ones for backup and so on. Another change in 8.0 is that we moved away from the historical kind of Wolf SSL and some other things. We found that our users really wanted to use OpenSSL, period. And we then took the consequences. We also decided to go with dynamic linking. So when you download MySQL, it will use the OpenSSL that your platform supports. So it will depend on your platform. There are differences in let's say Red Hat 6, 7, 8 on which OpenSSL version is used there. We also now have done support for FIPS compliance in this sense. You can reconfigure certificates without restarting the server. So in general, our users always tell us that we don't want to stop the server for any type of maintenance, so please make it dynamic all the time. And we are slowly getting the message. This is kind of a theme that we have internally. So this is a general guideline for anything we do. If we can't do it online, don't do it, kind of thing. Because in an OLTP transaction system, there is no such thing as a maintenance window. It doesn't exist. It's always up and running, period. And we added TLS 1.3 support and more stronger encryption for data at rest. So on the on the monitoring side, so just in MySQL in general, we have two types of kind of metadata information or monitoring information, if you want. There is the persistent metadata, which is stored in the data dictionary. 8.0 also have a transactional data dictionary, so we moved away from the old FRM files and these things that happened before. So information schema tables are now essentially views on top of InnoDB tables, the dictionary tables. And they have information of things that are persistent, like table names, column names, and any other things that needs to be persistent. And then we have performance schema tables, a different storage engine, which kind of, it's a normal table, it's accessed over SQL, so in that sense it does work normally as a tables, but this information is lost if you restart the server. So we use this to catch the current activity, like statistic performance-oriented measurements that doesn't really need to be persistent, which also makes it very kind of efficient to use here. Then we have sysschema, which is a set of stored routines that are more task-oriented, that uses information from performance schema and information schema. It's the general picture. So some examples of what we have added for performance schema in 8.0. This is server only. We have more for application. I didn't mention this today. So a few popular things that we implemented is what is the latency distribution for a given SQL statements. So we have kind of monitoring over time and give the distribution of the latency for the query. So typically, if you see that a lot of the queries start to use a lot more time, you have kind of a problem going on. Or if more of them are at the high end. It's sometimes okay to say, okay, one query did spend a lot of time. But like this 95% percentile thinking. But if this start to happen a lot, you probably have a problem that you need to dig into. Then you have data locks, so you can look at what user threads are waiting for which locks and who holds them. So we have a full overview on who is locking and who is waiting for locks. So by the way, I didn't mention that, but MySQL is a single process system, a multi-threaded single process system. So MySQL database is one process called MySQL D. SQL errors, so which errors have been sent back to clients and statistics about those errors. This is kind of very useful to monitor for monitoring purpose by DBAs. So when did you send an error, how often did it go? Also, we can look at configuration variable. What is the current value of the configuration value? Who set it? When was it set? And on management, So a major theme for us in general, and we have implemented a lot here in 8.0, is to eliminate the need to access the host machine. This is for environments where you typically don't have access to the host machine. There can be some cloud environments, it can be Docker environments and so on. But our general goal here is that you should not really need to log into the machine. And you should not need to restart the server. These are kind of two things. So there's been a lot of focus for us to say that, to fix these things. And I think we have largely done it. We have a few things left, but we are working on it still. MySQL have always had something called set persist. Set global. You can set the global variable, but it was not persistent. So if you restarted the server, the value was lost. Now we can do set persist, a config variable value, and this will be stored. And if you restart the server at some point, it will pick up the same. You can also restart the server remotely, and you can auto upgrade. The system now has logic to understand that I'm a new server version reading an old image, and based on the version information in the process itself and on disk, he makes decision about what to do on the upgrade. So try to be fast here. MySQL is more than kind of the MySQL server itself. We try to think in terms of one product strategy where we have components that should fit together, ship together, work together, and so on. An important development here is that we have the shell, MySQL shell. So our slogan here is ADA, that is the DevOps. ADA is smart. ADA is using the MySQL shell. That's kind of how we want to see the MySQL shell. So the MySQL shell is modern. It's have colorful prompt themes, auto-completion, syntax highlighting, context-sensitive help, command history, pager, less, more, output formats, and so on. It's flexible. You can run it in SQL mode, classic mode. You can run it in JavaScript mode, and you can run it in Python mode. So if you're, for example, a Python developer, you can just write whatever you want to do in Python there. It can run interactive or in batch. It can be used as an SQL client. It can be used to write document store applications with CRUD. It can do cluster admin and replica set admin that we'll speak about soon. It's extensible, so we both ship function, utility functions developed by us. We have a reporting framework where you can do show and watch on SQL statements, for example, over performance schema. You can write your own plugins in JavaScript and or Python. Moving on to clone. So clone is essentially if I have one master or one server and I want to have a read scale-out replica, a new one that doesn't exist before, I can more or less, I will show you the steps, but more or less I can tell I started a new replica, and I can tell it, get your data from this guy. And then they set up a stream communication, and it transfers all the state from the donor over to the recipient over the network, roughly at the speed of the network bandwidth in that case. So it's kind of simplify, instead of kind of creating a backup, moving it over, rolling in a backup, and so on. There are manual steps there. It kind of gets you fast provisioning. And in InnoDB cluster, all this is automated. So clone directly from SQL. I need a new replica. I do an install clone. I create a clone user or a clone password, and I grant privileges to that. I do the same on the recipient. The only difference is that I also currently need a donor list. This is an additional security step. And then I simply say clone instance from address identified by password. I can check status by looking up in performance schema. So in progress, what it started, it's been running for 4 minutes. I can also check on each of the stages. There is a file copy stage, a page copy stage, a redo log copy stage, file syncing, restart, and a recovery phase. So I will briefly show you InnoDB cluster, or explain what it is. So InnoDB cluster is a high availability solution. So we have it based on group replication in bottom. So there's a group replication implementation. Then there is a router that can route traffic to the right node in the group. And then you have the applications, of course, sending SQL through the router to the nodes. And you have the MySQL shell to manage and monitor the whole thing. So group replication is kind of a built-in solution that covers I would say all things that are needed in a HA setup. It's based on Paxos implementation, a lot similar to the SQLite talk that were earlier here today in the basic setup. So you can do things like initialize a group, detect node failure. It automatically detects node failure. It reestablishes a group. It elects a new primary if you are in a single primary mode. You can also run in multi-primary mode. You recover from failures. You can rejoin the group. You can grow and shrink the group. You can provision new members in the group. You have topology information in the group that the router can ask for what is the current topology, so on and so forth. The replication technology is much of it centered around this new group replication, the new developments in 8.0. We also have a player write set, so it's the slaves in master-slave communication can do more parallel work on the insert, or when it gets the replication stream over to the slave, it can execute a lot more in parallel than we could earlier. We also now based on the global transaction identifiers, which have the advantage that there is for each transaction it has a global ID that is valid in a bigger topology. So it's not only valid within a single instance, it's valid wherever, because these bin logis events are traveling quite far nowadays. Yeah, the group replication is just built on solid research and papers and published, Paxos and so on. Again, much of it similar to the previous talk we had. So things that are built in here, fault detection, so it's automatic detection of failed servers in the cluster, server fencing, so the automatic isolation of faulty servers from the application and the cluster. We can configure the data consistency level that also was talked about in the last talk. So we can have things like reading your own writes, and depends. You can configure it in various ways. It implements distributed recovery, so if one node fails, it can get information from other nodes to get up and be in the cluster again. There is flow control, to just ensure that you don't get replications, lag and things. It has automatic flow control that kind of slow down things a little bit for a while if things are getting out of hand. And there are membership services, so they know who is the members of the group and can communicate group membership. Yeah, I will do this in 5 minutes. It's okay. I will do this mini tutorial in 5 minutes. I think it's should be fairly easy. So this is kind of an overall InnoDB cluster setup. I want to show a configure instance, create cluster, add instance, remove instance, and rejoin instance. Everything here is automated and everything is controlled from the MySQL shell. We have read-write traffic into the router, and the router knows if you are in this. Here we show single primary mode, which is our default. So the red box here is the primary. The green ones are only for reads. So all updates and inserts and deletes goes to the red box. So what you do, you take 3 machines, you install MySQL on each of these 3 machines, and you start it, and each of the servers are governed by systemd. Keep it up and running. So I say configure instance to each of these 3 boxes. Then I point to one of them, and I say create cluster FOSDEM 2020. This then forms kind of a group. But if I say cluster status, it says your cluster is not fault tolerant. I need at least 3 to be fully fault tolerant, because I need to handle also network partitions. So if one box gets isolated from the others due to the network, the other 2 can form a majority, and this is how it works. I can add an instance, and I automatically can pick up to clone. So I already started one, so the next one will just take the information from the first one by doing a clone. The same happens with the third one, and now this screen dump just shows the progress report of a cloning activity. It doesn't need to worry about that now. I can do a cluster status. I see that the cluster is online and can tolerate up to 1 failure. Then I boot up the router from the shell. I start the router. I start traffic flowing into the system. Then just for demo purposes, I say kill one of the nodes. So the node leaves the group, it's dead. The other one detects it. They start electing, So what you show, they elected a new primary, so the second server here is now the primary. And there are various things depending on the scenario. If there are kind of 3 major scenarios in faults. One is that if I just kill it in Unix kill like I did here, it will just recover and go back to the group immediately. So there's really no additional action needed. But for example, if this node has been, there was a network failure and this node has been isolated and it took time to find out and fix the network problem and get it back in, it might be outdated. So it cannot, the group doesn't have enough binary log to be able to catch up the node because it's been gone for several hours or a day or so, potentially. And in this case, we will use the clone when it gets in. It will just pick one of them. You can even decide which one it will take it from, I think. But then it will clone itself and then come back to the group and catch up on the latest transaction by the bin logs available in the group. And last, and in this case, you have to do an explicit rejoin of the third alternative is actually the machine is broken. It will never come back in. You have to replace it, give it a new ID, and then you take a remove instance of the old instance, you add a new instance, and then you clone it and come back in. Okay, so what I did here was a rejoin instance, so I kind of thought that this was the network isolation problem. Actually, with a kill, I didn't have to do it because it would come in. This was more to show cloning can have a part in this. So then we are back to fault tolerance with these simple commands. Just mention that we have a ton of MySQL drivers. I also want to mention that we are open source. The GitHub, the open source is on GitHub. Just search for MySQL and you will find it. There's wide platform coverage. We support almost every platform. We now currently stick to C++ 14 standard. We try to modernize, getting more and more newer compilers with more and more modern constructs. We are doing a lot of cleaning up. We are working with ASAN and UBSAN and all these kind of quality tools to get the source code totally clean. We have moved to Google C++ style guide, and we have online documentation of the source code. There are more features in 8.0. There is a blog post that I keep up to date. You can go in here and look at, there's roughly like 300 new features in 8.0. That's it. You can reach out on Slack. You can reach us on, and thank you.
Thank you. And I think that there is the time for 1 or 2 questions. No? Oh.
Hi. Does group replication right now support only synchronous replication or asynchronous as well?
So group replication, whether it's synchronous or asynchronous, it is synchronous in a way, in the sense that you guarantee that when your transaction commits, actually the whole group will know that. So it's synchronous in that sense. But there's kind of an eventual consistency thing going on with Paxos that complicates the picture a little bit. But my short answer would be yes, it's synchronous.
Okay.
How hard is it to upgrade an existing system, an existing cluster, to 8?
So the question is how I upgrade a cluster from 5.7 to 8. Someone else can answer that. I think that we do have an upgrade path on that. I'm pretty sure of that. I'm not 100% how that, so I need to, sorry about I can't 100% give you an answer, but I'm pretty sure that there is an upgrade path from 5.7 to... Yeah, okay, so Fred will talk to you and give you the answer.
Okay, one last question.
Were there improvements in terms of storage management, meaning for SSD architectures, or?
Yeah, is there improvements for storage management? We pretty much assume, at least for production system, that you run on SSDs. And what kind of improvements are you thinking about especially? Like algorithms, or the optimizer will choose different things? We have logic in 8.0, or even in 5.7, I think, or is it 8.0 only? I'm not sure. That you will have different costs. You will detect that your table is on disk, and possibly the percentage on disk versus how much of it is in memory, and take that into account when you generate the plan. So in that sense, there is some optimizations.
Time is up. Thank you.